Hi and welcome to the video training of Rabbitmq. So Rabbitmq is a message broker. It is a multi-protocol messaging system and it is an open source software. It accepts and forwards messages. You can think about it as a post office. When you put the mail that you want posting in a post box, you can be sure that Mr. or Miss mail person will eventually deliver the mail to your recipient. In this analogy, Rabbitmq is a post box, a post office, and a postman. The major difference between Rabbitmq and post office is that it doesn't deal with paper. Instead, it accepts, stores, and forwards binary blobs of data, that is messages. Rabbitmq and messaging in general uses some jargon. Producing means nothing more than sending. A program that sends messages is called a producer. A queue is the name for a post office which lives inside Rabbitmq. Although messages flow through Rabbitmq and your applications, they can only be stored inside a queue. A queue is only bound by the host's memory and disk limits. It's essentially a large messages buffer. Many producers can send messages that go to one queue and many consumers can try to reach data from one queue. This is how we represent a queue. Consuming has a similar meaning to receiving. A consumer is a program that mostly waits to receive messages. Note that the producer, consumer, and broker do not have to reside on the same host. Instead, or indeed in most applications they don't. An application can be both a producer and consumer too. So basically Rabbitmq consists of three major parts. The first one is a producer, the middle one is the queue, and the third one is the consumer or the destination. So producer is the source and consumer is the target or destination, and queue is the intermediate processing system that manages when to send messages and deliver them. So first step is to download and install Rabbitmq. It is very easy, especially if you are on Ubuntu or Linux operating systems. Just go to rabbitmq.com/download. The simplest process that I followed is using Docker. So just run this command, docker run -it and all the string, and press enter, and the Docker will automatically download the Rabbitmq management application on your local machine and run it in the Docker container. So it will be available for your programming code, and you can easily implement and practice on Rabbitmq on your local machine. Okay, the prerequisites. This tutorial assumes Rabbitmq is installed and running on localhost on the standard port 5672. In case you use a different host, port or credentials, connection settings would require adjusting. So where to get help? If you're having trouble going through this tutorial, you can contact me through the mailing list or Rabbitmq community Slack. Okay, let's get started. So what we are going to do is we are going to build a hello world program using the Pika Python client. In this part of the tutorial, we will write two small programs in Python: a producer, that is a sender that sends a single message, and a consumer receiver that receives messages and prints them out. It's a hello world of messaging. In the diagram below, P is our producer and C is our consumer. The box in the middle is a queue, a message buffer that Rabbitmq keeps on behalf of the consumer. So overall design will look like this: P, Q, and consumer C. Okay, so Rabbitmq libraries. Rabbitmq speaks multiple protocols. This tutorial uses AMQP091, which is an open general purpose protocol for messaging. There are a number of clients for Rabbitmq in many different languages. In this tutorial series, we are going to use Pika 1.0.0, which is the Python client recommended by the Rabbitmq team. To install it, you can use the pip package management tool by simply running python-m pip install pika --upgrade. Okay, now we have Pika installed. We can write some code. Our first program send.py will send a single message to the queue. The first thing we need to do is to establish a connection with the Rabbitmq server. So let's get started and write some code. Actually, I already have this code written on my laptop. So by the way, you can get this code from my GitHub repository of Rabbitmq, which I'll share the link in this YouTube description. So just go there and you can clone the repository of this example from GitHub. Okay, so you need to add user bin environment Python, import the Pika library, and the second thing we are doing here is we are connected now to a broker on the local machine. Basically, this command connection equals pika.blocking connection, pika.connection parameters localhost. Localhost means 127.0.1, which is your local machine address. And then you have channel equals connection.channel. So if we wanted to connect to a broker on a different machine, we would simply specify its name or IP address here. So let's say you are in a big office, you have like 1,000 computers, and you want to connect to a broker which resides on a certain local intranet IP. You just give the IP address of that machine in these parameters, and your program send.py will be connected there. Next, before sending, we need to make sure the recipient queue exists. If we send a message to non-existent location, Rabbitmq will just drop the message. Let's create a hello queue to which the message will be delivered. So for that, we write in channel.queue_declare queue equals hello. At this point, we are ready to send message. Our first message will just contain a string hello world, and we want to send it to our hello queue. In Rabbitmq, a message can never be sent directly to the queue. It always needs to go through an exchange. But let's not get dragged down by the details. You can read more about exchanges in the third part of this tutorial. All we need to know now is how to use a default exchange identified by an empty string. This exchange is special. It allows us to specify exactly to which queue the message should go. The queue name needs to be specified in the routing_key parameter. Channel.basic_publish, and within the parameter we will passing the exchange, which is currently an empty string. Then we have the routing key, which is hello, and the body is hello world. And after that, we are sending print command using Python, and we are sending sent hello world. Before exiting the program, we need to make sure the network buffers were flushed and our message was actually delivered to Rabbitmq. We can do it by gently closing the connection.close. Let's say if the sending doesn't work. If this is your first time using Rabbitmq and you don't see the sent message, then you may be left scratching your head wondering what could be wrong. Maybe the broker was started without enough free disk space. By default, it needs at least 200 MB free on your hard drive and is therefore refusing to accept messages. Check the broker log file to confirm and reduce the memory limit if necessary. You can do this by setting the parameter disk free limit in your configuration file. Okay, let's get into the receiving part. Our second program receive.py will receive messages from the queue and print them on the screen. Again, first we need to connect to Rabbitmq server. The code responsible for connecting to Rabbit is the same as previous. The next step, just like before, is to make sure that the queue exists. creating a queue using queue_declare is idempotent. We can run the command as many times as we like and only one will be created. So channel.queue_declare, and within the parameters say queue equals hello. You may ask why we declared the queue again. We have already declared it in our previous code. We could avoid that if we were sure that the queue already exists. For example, if send.py program was run before, but we are not yet sure which program to run first. In such cases, it's a good practice to repeat declaring the queue in both programs. Okay. Listing queues. You may wish to see what queues Rabbitmq has and how many messages are in them. You can do it as a privileged user when using the Rabbitmq CTL tool. Sudo Rabbitmq tool list queues, or on Windows omit the sudo. Messages from the queue is more complex. It works by subscribing a callback function to a queue. Whenever we receive a message, this callback function is called by the pk library. In our case, this function will print on the screen the contents of the message. So we are declaring a callback function, def callback. It receives three parameters: channel, ch, method, properties, and body. And we are going to print received, and we are going to print the body that we received with the callback function. Next, we need to tell Rabbitmq that this particular callback function should receive messages from our hello queue. So we declare channel.basic_consume, and we pass in queue equals hello. Queue hello is the queue name, and then we say auto is acknowledgement equals true, and on message callback equals callback. So we are telling this function that our callback function is called callback. For that command to succeed, we must be sure that the queue which we want to subscribe to exists. Fortunately, we are confident about that. We have created a queue above using queue_declare. And finally, we enter a never-ending loop that waits for data and runs callbacks whenever necessary, and catch keyboard interrupt during program shutdown. So print waiting for messages. To exit, press Ctrl C, channel.start consuming. So here we have an if condition: if name equals __main__, try catch block, main accept keyboard interrupt, print interrupted, try system.exit 0, accept system exit 0, os.exit_exit 0. Now we can try out our programs in a terminal. First, let's start a consumer which will run continuously waiting for deliveries. So let's get into some execution part. Okay, here is my terminal, and what we need to do is we need to run the Docker first. So this is the command that I showed you in the installation and downloading and installation slide. So just run that, and this will execute the Docker image. Okay, the configuration logger has started, and you can see the Rabbitmq have successfully started. You see here server startup complete, 4 plugin startup, Rabbitmq management, web dispatch management agent completed with 4 plugins. So let's open a new terminal, and here I'm going to my project directory of Python and Rabbitmq. Here I have hello world directory, and there I have our two small programs, receive.py and send.py. So what we are going to do is we are going to run receive.py first. So Python receive.py, and here we go, waiting for messages. To exit, press Ctrl+C. Okay, let's start a new window and new terminal window, and here we are going to run send. Okay, so consumer started first, Python receive.py. Now start the producer. The producer program will stop after every run. So Python send.py, and here you go, it says send hello world. And if we go to the consumer is says received hello world. So let's go into our program, and what I'm going to do is I'm going to send a different string. So it can say hello tech Weber, thanks for this useful tutorial. Okay, save this program and I'm going to execute it again, and it says sent hello world, thanks for this useful tutorial. And at here we got hello world again, but we need to start this again and send the message again. This time it says thanks for, okay, because the body is hello world as well, so we need to change the body as well. Okay, save it, and now it should go as we expect. Alright, we have now hello tech Weber, thanks for the useful tutorial. So you can easily customize this basic program of sending and receiving as per your needs, and play with Rabbitmq, and slowly and gradually you can master Rabbitmq in no time. So we have learned how to send and receive a message from a named queue. If you need any help, feel free to contact me. My email is umehmood@gmail.com. My LinkedIn ID is linkedin.com/in/umehmood. My Twitter handle is Osman_TechWeber. So I want to share you something which I have learned in the past 19-20 years of my experience in software industry. Basically, whenever a new technology comes in, these are basically just buzzwords. When you touch them, you realize that they were nothing but just couple of configuration or commands, and you have easily and completely grabbed them with no complexity. So I hope you liked this video. See you next time in the part 2 of this video series.